Okay, dear students, today we will see the topic of explainability, concept and real-time use part 2. So in today's world, deep learning models have become extremely powerful, especially in tasks like image recognition, speech processing, and decision-making systems. However, the major problem is that these models behave like black boxes. So they give highly accurate results, but we do not know how those results are generated internally. So this lack of transparency become a serious issue in the real world application such as healthcare, finance and autonomous driving. For example, if an AI system predicts the disease or rejects a loan, we must understand the reason behind that decision. So this is where the visualization plays a crucial role. Visualization techniques help us see what the AI model focusing on, how it is making decisions. So this improve the trust, transparency and validation without explainability. So even a high accurate model cannot be fully trusted. Therefore, this topic is not just theoretical but essential for building responsible and reliable AI systems. We can move the next slide. Now see the deep visualization techniques in explainable AI. Deep visualization is a technique used to understand how neural networks make decisions. It converts the hidden internal activities of neurons into visual forms that humans can interpret. In deep learning models like CNNs, thousands of neurons process input data, but their operations are not directly visible. Deep visualization helps in exposing these hidden layers and showing which parts of input are important. The need for this arises because CNN act like a black boxes, making it difficult to understand their reasoning. In critical applications like healthcare or autonomous systems, even a small error can lead to serious consequences. Visualization helps us identify whether the model is focusing on the correct features or not. It essentially answered the question, what is happening inside the model by making AI decisions visible. Deep visualization bridges the gap between machine intelligence and human understanding. We can move the next slide. This is the visual diagram of deep visualization. So it is used to understand how the neural network make the decision. Okay. So what is deep visualization? Which means main techniques in deep visualizations. So deep visualization, already I told that how the neural network make the decisions, convert the hidden neuron activity into human understandable visuals, shows important region, features and patterns. CNNs act like a black boxes. Errors can be dangerous and visualization exposes model focus. This is the visual diagram of the main techniques on the deep visualization. There are the three main techniques. The first one is activation map. Then second one is GradCam, which means gradient weighted class activation mapping. Then third one is sensitive analysis. So each of these techniques focuses on a different aspect of understanding the model. Activation maps show which features are being detected at different layers of the network. So GradCam highlights the specific regions of input that influence the final decision. Sensitive analysis measures how changes in input affect the output. Despite their differences, all these techniques aim to answer one fundamental question: which part of this input influenced the decision the most? So this question is the heart of explainable AI. Again, I repeat the question: which part of the input influenced the decision the most? So by using these techniques together, we can get a complete understanding of how a model processes information, make a decisions, and whether those decisions are reliable. This is the visual diagram. Then activation map. So the activation maps are visual representations of how neurons respond to an input image. They show which part of the image activates certain neuron in the network. These maps are usually generated from convolutional layer in CNN. In early layers, the network detects simple features like edges and the lines. In the middle layers, it identifies the shapes and textures. In deeper layer, it recognizes the complex objects like faces or specific patterns. So this hierarchical learning the process what CNN's powerful. Activation maps help us understand this progression clearly. So instead of treating the network as a black box, we can see how it gradually built a knowledge from a simple to complex features. So this make it easier to debug the model and ensure they are learning a meaningful and pattern rather than the irrelevant details. So consider a face recognition system. This is a visual diagram of CNN layer 1, layer 2 and classifier. As already I told that layer 1 to take the sum part, layer 2 to take an sum part, layer 3 to take an sum part. The next one is face recognition of real-time activation map. Example. So consider a face recognition system as an example. When an image of a face is given as the input, the CNN process it identify the key features like eyes, nose, and mouth. Activation map highlight these regions, showing that the model is focusing on important facial features. So this confirms that the model is working correctly. So however, if the activation map highlight the irrelevant areas like the background, it indicates a problem in the model. So this can lead to incorrect predictions. Therefore, the activation maps are useful for verifying whether the model is learning the right features. They also help in identifying bias and improving model accuracy. In real world applications, this ensures that the system is reliable and trustworthy. This is a visual diagram of face recognition. This is a genuine face, this is a fake face. GradCam. So gradient weighted class activation mapping is a powerful visualization technique used to understand model decisions. It works by using the gradients of target class to produce a heat map. This heat map is then overlaid on the original image to highlight important regions. So the key advantage of GradCom is that it provides class specific explanations. So this means it shows why the model predicted a particular class, unlike activation maps which show general feature learning. So the GradCam focuses on the final decision. It works with almost any CNN architecture, making it widely applicable. So this technique is especially useful in applications where understanding the decision is critical. So this is a visual diagram of GradCam. So the GradCam process, which means how it works. So the GradCam process involves the many steps. First, a forward pass is performed where the input image is passed through the network to get a prediction. So next, a backward pass is done to compute gradients with respect to the target class. So these gradients are then used to weight the feature maps. Finally, a heat map is generated and overlaid on the original image. In this heat map, the red regions indicate high importance, while the blue regions indicate low importance. So this visual representation helps us clearly understand which part of the image influenced the model's decision. The process may seem complex, but the output is very intuitive and easy to interrupt. See, this is right. So red regions indicate the high importance, and then blue region indicates the low importance. In healthcare, the GradCam is widely used for tasks like a tumor detection. When CNN predict the presence of a tumor, GradCam highlight the affected region in the scan. So this allowed the doctor to verify whether the AI is focusing on correct area. If the highlighted region matches the actual tumor location, it increases trust in the AI system. If not, the model need to improvement. So this is extremely important because incorrect predictions can have serious consequences. So GradCam not only improve the accuracy but also support the clinical decision making. It act like a bridge between AI and the human expertise. Right? Have you understood? So, the benefit of us increase the trust in AI diagnosis. This is a visual diagram analysis concept here. So, sensitivity analysis is a technique. It is used to measure how changes in input affect the output of a model. It helps in identifying which features are most important for a prediction. In a simple terms, it answers the question, if I change this input, okay, value slightly, how much does the output change? Again, I repeated the question. If I change this input value slightly, how much does output change? So this help in understanding the robustness of the model. A good model should not change in the decision drastically for a small input variations. A good model should not change in the decision drastically for a small input variation. So sensitivity analysis ensure the model is stable and reliable. This is the visual diagram after the changing slightly. It does not affect anything. Okay, for example, sensitivity analysis in real-time scenario. Consider a loan approval system as an example. If we slightly change the applicant's income and the decision changes significantly, then income is a highly sensitive feature. On other hand, if a changing age does not affect the decision, then age is less important. So this analysis helps us understand which features influences the model the most. It also helps in the detecting bias. For example, if the model sensitive to irrelevant features like a gender or uh, ethnicity, then it is indicate unfair decision making. So sensitive analysis help to improving the fairness and reliability. So hope you understood what is sensitive analysis, right? So sensitivity analysis, real-time examples, right? Any doubt regarding this? We can move the next one. This is a visual diagram. Five challenges adapting AI in the loan management automations. Data privacy and security, bias and fairness concerns, lack of transparency and interpretability, limited availability of data, cost of implementations. Then comparison of the technique. The three techniques we will compare everything. Activation map, gradcam and sensitivity analysis. Each serve different purposes. So activation map help in understanding feature learning at a different layers. GradCam provide the class specific visual explanations, especially for image based models. Sensitivity analysis focuses on relationship between input and output, helping us understand model robustness. Together, these techniques provide a comprehensive understanding of the model. So they complement each other and are often used together in real world applications. This is a visual diagram. Why deep visualization is important? Explainability is essential for building trust in AI systems. It helps developers debug models and identify the errors. It prevents the biased learning by exposing the hidden patterns. In critical domains like healthcare, finance, and autonomous system, explainability is a mandatory. So without it, AI system can't safely deployed. So explainable AI ensure that the models are not only accurate but also transparent and accountable, right? This is the visual diagram of ML life cycle. So summary recap. So deep visualization reveals the hidden intelligence. Activation map, what features are learned. GradCam, where model focuses. Sensitivity analysis, how the stable decisions are essential for ethical and safe AI. Before concluding, I would like to tell one thing. Imagine you are using a medical AI system in a hospital. A patient comes in and the doctor uploads an MRI scan into the system. Within the second, the AI says tumor detected. Now, pause for a moment and think like a doctor. Will the doctor blindly trust this result? Definitely not. So the doctor will immediately ask, where exactly is the tumor? Why did the AI say this? So this is the very this is where our topic today become the important for deep visualization. So AI is more powerful, but the most deep learning models, especially CNNs, behave like a black box. They give the outputs, but they don't explain how they arrived at those outputs. So in real world scenario, the healthcare, autonomous driving, uh, finance, this is risky. We can't depend on the system we don't understand. So deep visualization helps us see what the AI is seeing. Now let us walk through the what is actually happening inside the medical system. When the MRI scan is given as input, the neural network processes it layer by layer. In the initial layer, the system does not understand tumor or disease. Instead, it detects very basic features like edges, lines, and simple patterns. As we move the deeper into the network, the system start identifying the more complex structures like shapes and textures. Finally, in the deep layers, it recognizes the high-level features like abnormal tissues or tumor regions. Now the question is, how to visualize all this? That is where activation map come into the picture. So imagine turning the neural network into a transparent system where you can see which neurons are activated. Activation maps show which part of the image are triggering strong responses in the network. So in our MRI example, if the activation map highlight the tumor region, we can confirm that the model focusing on the correct area. But if it is highlight some irrelevant region, then we know something is wrong. So this is extremely useful for debugging models and ensuring they are not biased. Let me give you a simpler example. Suppose you upload a photo of your face into a face recognition system. The AI predict your identity. Now, using activation map, we can see which part of the face the model is focusing on: eyes, nose, mouth. If the model is focusing on the background instead of facial features, then the system is not reliable. So the activation map help us understand what the features are being learned at the different layers. Now let us move the more powerful technique, GradCam. Okay, GradCam. So the GradCam is one of the most powerful. This is the most widely used in the visualization methods. Instead of just showing the neuron activations, GradCam tells which region of the image influence the final decision. It produces something called heat map. In this heat map, the red areas indicate high importance and the blue areas indicate low importance. Let's go to back our healthcare example. The AI predicts a tumor. The GradCam generates the heat map and overlays it on the MRI scan. Now the doctor can clearly see which the region AI consider important. If the highlighted region matches the actual tumor location, then the doctor gains confidence in the system. If not, the model is need a improvement. This is the how explainability build the trust. Now think about the another real world case. Autonomous driving. So a self-driving car detects the stop sign and decide to stop. Using the GradCam, we can visualize whether the AI actually focused on the stop sign or got confused by some background objects. If the model is focusing on the irrelevant features like trees or shadows, it could lead to dangerous. So visualization is not just for understanding, it is for safety. Now let us move to the third concept. What is our third concept? Sensitivity analysis. So this is slightly different. Instead of visualizing the internal layers, we test how the sensitive models is to change in the input. In simple terms, we ask, if a slightly change the input, how much does the output change? Let's taking the banking example. Suppose an AI system is used for loan approval. A person applies for a loan and the system rejects it. Now we slightly increase the income value. If the decision suddenly changes from rejection to approval, then income is highly sensitive in future. But if changing the age does not affect the decision, then age is less important. So this helps us identify the which features are influencing the model most. This is very important for fairness. Imagine if your model is highly sensitive to gender or caste instead of income or credit score. That means the system is biased. So sensitivity analysis that help us to detect such issues and improve the model. So it is not just about performance. It is about ethical AI, right? Now let's combine all the three techniques in one real world system. Suppose you are building an AI model for disease detection. First, the activation map help you understand what the feature model is learning. Next, the GradCam shows where the model is focusing in the image. Finally, the sensitivity analysis tells how the stable and reliable the model when the input change. So together these techniques give a complete understanding of the model behavior. Now think from industry perspective. Companies cannot deploy AI system blindly. They need validation, trust and accountability. So deep visualization provide that. It helps a developer to debug the models. It helps the user to trust the prediction and help the regulators ensure the fairness. That is why explainable AI is becoming mandatory in the domain like a healthcare or finance or autonomous system. So the key idea you should remember this: AI is not just getting the right answer. It is about the understanding why the answer is correct. Activation map tell us what features are learned. GradCam tell us where the models focusing. Sensitivity analysis tell us how the robust the decision is. So together they make a AI transparent, trustworthy and responsible. Hope you understood the recap. This is the difference between machine learning and a deep learning diagram. So deep visualization play a key role in explainable AI. Activation maps show that features are learned. GradCam shows where the model focuses and the sensitivity analysis shows how the stable the decisions are. Together they reveal the hidden intelligence of deep learning models. So these techniques make a AI system more transparent, trustworthy and ethical. As the AI continues to evolve, explainability will become even more important in ensuring safe and responsible use. Imagine you are using a medical AI system in a hospital. A patient comes in and the doctor upload a scan MRI, right? The same concept will be here. So anyway, hope you understood the concept of three techniques, right? Thank you.